Hello, my dear students. Welcome back to my YouTube channel. Today, we are going to discuss the part second of the kinematics. So, let's start. So, this is my first numerical of the part second. So, let's solve this numerical. Yeah. So, it states that a ball is dropped from a high rise platform at t equals to 0, starting from rest. Okay. Let us make this sort of figure firstly. We have a ball, we are dropping it, right? So initial velocity is 0 and g will act on it, and g is 10 meters per second square. Okay, after 6 seconds another ball is thrown downwards. So after 6 seconds, so we have the velocity given to be 6 meters, or it's not 6 meters, right? So we have some velocity v. Yeah, so we have some velocity v. Then it will also go under the motion under gravity, that is g equals to 10 meters per second square. Yeah. Uh, Two balls meet at t equals to 18 seconds. That means after 18 seconds, these balls will collide with each other. So we have to find out the this velocity v. How we can do it? We can use the equation, right, to get the answer. So, so first of all, I will write first equation for this one. So I can write height, right? What is height, sir? Height is equals to ut plus 1 half of gt square. Then, as we are dropping it, so its initial velocity be 0. So I will put it as a 0. So h came out to be, so it is 1 by 2 g. What is t? T is 18. So I can write 18 square. First equation. The second equation, this one, I will use same equation, right? So it is h, u is v, and t. What is t? T is given to be 18 seconds, but here we don't need to put the 18. Why? Because after 6 seconds, that means 18 minus 6. So I can write for this one, time of collision would be 18 minus 6. So it came out to be 12 seconds. So I can write here 12 seconds Vt plus 1 half of g. G, and it will be 12 square. They will collide, no? So if they will collide, so these height will be the same. So I will equate these two equations. So what I can write now, I will write 1 by 2 g multiplied by, first of all, I will just put all the values now. So it came out to be 10 divided by 2 into 18 equals to, I will take 12 common, so I will have 12 now. Then we have v plus 10 by 2, it will be 10 by 2 multiplied by 12. Yes. So 2 1 2 5 is 10. So we have 5 multiplied by 18 multiplied by 18 whole divided by 12 equals to 560. It is v plus 60. Clear? So 2 6 are 12, 2 9 is are 18. 3 2 are 6, 3 3 are 9. Clear? 5 3 are 15. So we have 15 multiplied by 18. Yes. 15 multiplied by 18. Then we have 15. 5 3 are 15, 18. Whole divided by 2 minus 60 equals to v. So yeah, I can do one more thing. 2 1s are 2, 2 9s are 18. We have 19 into 5 minus 60. What we have now here? We have 15 into 9. 545. 9 1s are 9. 9 plus 4. That is 13. Minus 60 came out to be v. 5 minus 0, 0. No, it will be 5, right? And 13 minus 6, that would be 7. So v came out to be 75 meters per second. Clear? So I guess answer number 75, option number A is correct. Yes. Now, second question is on the screen, and question is like, a particle has initial velocity. So initial velocity is given to us a v, and acceleration is given to us. Time is also given to us. What we need to find? We have to find out speed. That means final speed. So we know that we have the equation v is equals to u plus a multiplied by t. We have to find out v. So put add v as it is. What is u? U is 3 I cap plus 4 j cap. Then a is given to be 0.4 I cap plus 0.3 j cap, then we have multiplied by 10. So can I write it as a 3 I cap plus 4 j cap? It will be a 4 I cap plus 3 j cap. It will be 7 I cap plus 7 j cap. V in a vector form, right? So what would be its magnitude now? It will be 7 square plus 7 square, it is more. I guess it is 7 root 2 meters. It is units, right? 7 root 2. And I guess option number B, 7 root 2 is my correct answer. Okay, next numerical. Next numerical is a particle moves at distance x in a time t according to the equation, and one equation is given to us. The acceleration of the particle is proportional to. So we have to find out the relation between acceleration, velocity, acceleration, and the distance. How we can do it? Look. So look, x is given to us, and it is given, the equation is t plus 5 inverse. So I need to find out it is velocity. So velocity is nothing, it is differentiation of x with respect to t. I guess it came out to be -1, then t plus 5, -1, So I can write it as a -1, t plus 5 minus 2. One more differentiation, so I can write acceleration came out to be dv by dt. It came out to be -1 minus 2 t plus 5 minus 3, right? So I can write, look now. So what I can write now, so my x is t plus 5 minus 1. Velocity is t plus 5 minus 2. I can also write it as a, sir, I will take 2 in the left side, so it will be v1 by 2 equals to t plus 5 minus 1. Done? If I look, what is acceleration now? Acceleration came out to be, sorry, it is t plus 5 minus 3. Clear? It is t plus 5 minus 3. So can I write one thing? Can I write one thing? And what is that thing, right? So I can write here that a 1 by 3 equals to t plus 5 minus 1. In this place, if these two are equal, now we can equate these two also. Yes, sir. Can I write then v1 by 2 equals to a1 by 3? That means a is equals to v3 by 2. Acceleration is what? Velocity 3 by 2. That means velocity 3 by 2. This is correct option. Now we need to find out in case of distance, right? So look, t minus 1 is distance 1. So there are 3. So can I write it as a equals to x power 3? Equals to x power 3. So we have x power 2, x power minus 2. That means only option number A is correct. Now moving to the next numerical. A man of 50 kilogram mass is standing in a gravity-free space at a height of 10 meters above the floor. Then he throws a stone of 0.5 kilogram mass downwards with speed 2 meters per second square. When the stone reaches the floor, the distance of the man above the floor will be. Clear? So we can do one thing now. Look now. If we assume stone and the man as a system, so we can use the conservation of momentum because there is no net external force being applied on it, right? So we can use the conservation of momentum, and conservation of momentum, I can write m1 u1 plus m2u2 equals to m1v1 plus m2v2. Both are at rest initially, so these are 0. So I can write m1v1 equals to m2v2. Done. M1 is the mass of person, that is 50 kilogram, velocity v1. M2 is the mass of the second one, that is 0.5, and velocity v2 is going to be 2. So 50 v1 equals to 1. v1 is 1 by 50 meters per second. That means if the stone is going downwards with some velocity 2 meters per second, opposite to it we have is minus now. So opposite to it we have the velocity of the man, and the velocity of the man is 1 by 50 meters per second. Okay, so by this velocity the man will go away from the surface, that is more than 10 meters, more than 10 meters. So now we have to find out the timings in which he can, this velocity is there, right? Timing. So can I write like this? So this is one equation. This is my first equation. Then what I can do right now, what is time? Time of stone to hit the ground. So is time equals to distance by speed? Yes, sir. It would be distance by speed. What is the distance covered by the stone to reach the ground? 10 meters. What is the speed of it? 2. 5. So time is equals to 5 seconds. So 5 seconds is the time in which the particle will hit the ground. So in the same timing, so we have to find out what should be the displacement of your man from that particular point. Timing is given to us, velocity is given to us, we have to find out distance. So what is distance now? Is the distance equals to speed into time. What is speed? 1 by 50. What is time? It is 5. So I can write distance came out to be 1 by 10 and it is 0.1 meter. Initially my distance is how much? Initially my distance is 10 meters. So now we have 0.1. So my total distance, right? So my total distance is equals to 10 plus 0.1 meter, which came out to be 10.1 meter. I guess option number B is correct. Okay. Next numerical. So we have this one. A particle starts its motion from rest. Okay. From rest means that means initial velocity is going to be 0. Under the action of constant force. So we have the constant force. Constant force means we can use the equation of the motion. If the distance covered in first 10 seconds is S1 and distance covered in 20 seconds is S2, then we have to find the relation between these two. Then how we can do it? Look now. What is S1? ut plus 1 half of at square. U is 0. So S1 came out to be 1 by 2 acceleration, that is A. What is T? So T is going to be 10 square. First equation. For second one, similarly, I can write S2 equals to 1 by 2A 20 square. Now, if I take the ratio of these two, so we have 1 by 2A 20 into 20 whole divided by 1 by 2A 10 into 10. Cancel out. So we have 4. So S2 came out to be 4 times S1. S2 is 4S1. S2 is 4S1. Option number D. Option number D is correct one. Next numerical. A distance traveled by a particle starting from rest and moving with constant acceleration is this much. In the third second means, right? The formula is Snth, u plus a by 2, 2n minus 1. 2n minus 1. Once again, yes. So what I can write now? I can write Snth, which came out to be u plus a by 2, 2n minus 1. I guess it is 0, right? This one is 0. So 1 by 2, a is given to be 4 by 3. Then we have 2, n is which second? Third, 2 minus 1. So we have 2. So we have 2 by 3. Then we have 6 minus 1. So 2 by 3, it is 5. My answer is 10 by 3 meters. 10 by 3, option number A is correct. Next numerical, a particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meter per second to 20 meter per second while passing through a distance of 135 meter in t. We have to find out the value of t. Okay, initial velocity is given to us, a final velocity is given to us. What I need to find? Time t, right? I need to find out now timings t. So how I can get it? So my equation is v equals to u plus at. V is I guess 20, so 20. U is 10, 10 plus a we don't know, t we don't know. One equation, two variable, impossible to solve. Is there any other way by which we can solve it? Yes. V square minus u square equals to 2as. Okay. What is V? 20. So we have 400 minus 100 equals to 2a. What is S? S is 135. So I can write 300 equals to, I guess it is 270 a, right? So a came out to be 300 by 270. I guess it is 1.1 something, right? Okay. So I can write a t came out to be 10 t. What is a? A is 1.1 something. It is 1.1 into t equals 10. T came out to be 10 by 1.1. Look, we have 10 by 1.1. It is 9 point something, right? My answer is 9. My answer is 9 seconds, approximately 9 seconds. Now, next numerical. Okay, a particle shows distance time graph. If we have distance time graph and we need to find out velocity, so we have to find out tan theta. Look, from this particular figure, so for A1, this is my theta. For B, this is my theta. For C, this is my theta, right? D, this is my theta. If you can see from here, no, the theta for D is maximum. No, C is maximum. C is no, it is straight line, something like that. Yeah, it is maximum, right? So I guess option C, maximum slope. So you can write maximum slope, maximum velocity. So at point C, theta is max. Therefore, velocity is max, right? Okay. Next, okay. A particle moving along an x-axis has acceleration f. Okay, f is acceleration at time t, given by f equals to f naught 1 minus t by t, where f naught, here is f naught and t are constants. Okay. At t0, velocity is 0. In the time interval t0 and instant when f is 0, velocity. We have to find out velocity. So what is given to us? Acceleration. So if you want to find out velocity from acceleration, I guess we have to do the integration first of all. What is acceleration? Sir, it would be dv by dt, then it would be dv, then we have to integrate dv. Okay, look, I can write, sir, f equals to f naught 1 minus t by t. So f naught, I can write it as a dv by dt equals to f naught 1 minus t by t, right? So I can write dv came out to be f naught 1 minus t by t, then we have a dt. I need to integrate it, but we don't know the timings, right? So look now, at t equals to 0, v equals to 0. If at t0, v0, so my f will be 0. F will be 0. So from this equation, can I write 1 minus t by t equals to 0? Yes. So my t will be t. This is my, now what? 0 to t. These are my limits, right? So I can write v equals to f is constant. I can take f naught outside. Then we have the integration of 1. That would be my t. Then we have a t square. 1 by t is constant. T square by 2. We have 0 to t, right? 1t can, no, we cannot cancel it like this. So it would be now capital T. Now I will put the values, right? So v came out to be f naught t minus t square by 2t. Now I will cancel it out. So v came out to be f naught t minus t by 2. So again, v equals to f naught t by 2. So again, this is my answer. F naught t by 2. F naught t by 2. Yeah, option number A. Option number A is, I think, matching with it, no? Yeah, option number A is correct. Next one. A car moving from x to y with a uniform speed. X to y with a uniform speed vu. And return to y. X to y with a uniform speed and, okay, it is vd. We have to find our average speed in a round trip. I guess the distance from x to y is same as that of the v to x, right? y2 x. If the distances are same, now we have the kind of shortcut now where we can find out the average velocity. That will be 2 times va vb divided by va plus vb. 2, what is va? Va is vu, it is vd divided by vu plus vd, right? So I guess I need to match it now. So it will be 2. I think only one option number b is matching with it, so option number b is correct answer. Done. We have now next numerical. What is my next numerical now? So my next numerical will be a particle started from 0, 0, moves in a straight line in xy plane. Its coordinates at a later time are under root 3, 3. The path of the particle, this one, makes it the x-axis. So we have to find out the theta. How we can get it? Look. So xy 0, 0, 3, 3. This theta. This would be my under root 3. This would be my 3. What is tan theta? P by B. What is P? P is 3 by under root 3, right? So I guess tan theta came out to be my, look, I can do it like this now also. There is no issue. So it will be 3 root 3 by 3, then root 3. It will be tan root 3. So my theta came out to be 60 degree. Option number D is correct. Okay. Less than 40 seconds to do this numericals. So the position x of a particle with respect to time t along x-axis is given by, okay, where x in meters and t in seconds, what will be the position of the particle when it achieves maximum speed? Okay, so there is a maximum speed. Maximum speed means where the acceleration will be 0. At that particular instant, where the acceleration is 0. Clear? So look now. So x is equals to 90 square minus t cube, where x is meters and t is seconds, right? So can I write now dx by dt equals to 18t minus 3t square? Okay, one more time differentiation. No? D square x is divided by dt square 0. It will be 18 minus 90. I guess 90 came out to be 18. No, it is 3 to the 6. No, it is 6, right? It will be 6 now. 60. I need to just, it's 60. The t came out to be 18 by 6 is 3 seconds. So in 3 seconds, it will get the, at the 3 seconds, it will get the maximum speed, right? So what I need to get? Position of it. I need to get it is position. So I guess x came out to be 9, 3 square minus 3 cube, 9, 9, 27. 81 minus 27. So 11 minus 7, 4. Then we have here 7 minus 7, 7 minus 2, 5. So my answer is 54 meters, right? My answer is 54 meters. Look, for angles of projection of a projectile at angle 45 minus theta and 45 plus theta, the horizontal range described by the projectile are in the ratio of. We know this is 1,1, but I will just show you, right? So how we can get it now? Look, what is range? U square sine 2 theta by g. This is my range formula. So for first angle, I can use u square sine 2. What is theta? It is 45 minus theta. Range 2, okay, divided by g also. Second one, u square sine 2 45 plus theta divided by g. So this equation I can write it as a r1, that is u square sine 90 minus 2 theta divided by g, r2 u square sine 90 plus 2 theta divided by g. So this came out to be u square cos 2 theta by g. This came out to be u square, same, cos 2 theta by g. Both are same. So if I can take ratio r1 by r2, we will get 1 by 1. That's why my answer is 1 by 1. Next numerical, a particle moves along a straight line OX. So we have a straight line OX like this, OX. At time t, the distance x of the particle from O is given by. So x is given by 40 plus 12t minus t cube. How long would the particle travel before coming to rest? Before coming to rest means where the velocity will be 0, where my velocity will be 0. Okay. So, sir, I can do dx by dt. It will be 0. It will be 0 plus 12 minus 3t square. Yes? Okay. So, it's t square, right? So, I can write 3t square equals to 12. But 3 and 4 to 12. So, t square came out to be 4. So, t came out to be 2, right? Yes, after 2 seconds. So, I need to find out distance between these two from 0 to 2. So, can I write the final minus initial? Final means at 2, initial means at 0. So uh, at 2, right? So we have the equation by which I can get it. I can write this one. No? Look, x at 2, 40 plus 12 into 2 minus 2 cube, 40 plus 24, 8. So I have here 64 minus 8, 56. So we have now here 56 meters, right? And x naught, that's x 0. What is x 0 now? It will be 40, only 40, no? Only 40. So I can write delta x came out to be x final minus x initial. That means 56 minus 40. It will be 16 meter. Is there any option? Yes, 16 is option D. 16 meter is my correct option. Next numerical, two bodies. A, which is having mass 1 kg, B, which is having mass 3 kg, are dropped from height 16 meter and 25 meter. Different heights. The ratio of time taken by them to reach the ground is. Okay, so we have to find out time taken by them to reach the ground. Okay, so what is the equation? H equals to ut plus 1/2 of at square. So drop that means it is 0. So h is equals to 1 by 2 at square. H1, T1. So I have H2 equals to 1 by 2 a T2 square. So I will take this ratio. So this will cut it, right? So H1 by H2 came out to be T1 by T2 whole square. So T1 by T2, I will write it as the under root of H1 by H2. H1 is 16, H2 is 25. So I will have 4 by 5. 4 by 5. Option number D is correct. 4 by 5. Yeah, correct one. Next numerical. If the angles between the vector A and B is theta, the value of the product B cross A dot A. Look now. So when we are doing the vector product between two vectors, we will be having a third vector, and the third vector will be perpendicular to both A and B. That is suppose this the vector will be the C, right? So C vector is perpendicular to A as well as B. So now I need to do what? A dot product of the C vector which is perpendicular to A. Clear? So can I write it as CA here, then cos theta, but cos theta is 90, so my value will be 0. That is 0 answer. Next numerical, it is two boys. Two boys are standing at the ends A and B. Okay. A ground where AB is A. Okay. So we have like this. AB, this one is A, this one is A. The boy B starts like this. That's why his velocity will be a v1. Okay. The boy A starts running simultaneously with velocity v. Okay. And catches the ball in time t. So it will go like this, and it will catch. Let us suppose it will catch the boy after time t. Its velocity is v. This is theta. So we have to find out timings at which it will get the boy. Okay. How we can get it? Right angle triangle. So can I write like this? Let us suppose it is A, B, C. I can write AC square equals to AB square plus BC square. So I need to get, let us say AC. Yes. What is AC? It is distance, no? And distance is speed into the time. I can write VT whole square AB is A square plus BC is given to be V1 T square. I can write V square T square equals to A square plus V1 square T square. V square T square minus V1 square T square equals to A square. I will take T common, so we have V square minus U square. No, it is not V U square, no, it is V1. Here we have what? V square V1 square. No, 1 second. V square V1 square equals to A square. T square came out to be A square whole divided by V square minus V1 square. So can I write like this now, that T is equals to under root of A square divided by V square minus V1 square, or A divided by under root of V square minus V1 square. But why my answer came out to wrong? 1 second. So my answer will be positive. Why it came out to be negative now? So I can write AC square. VT, it is V square T square, yes, square. But it came out to be negative now. There is no option with negative, there is everything is positive. I guess my answer is correct, no? My answer is correct. Yeah, there will be some sort of negative, no negative. Yeah, there is some sort of correction to it. I guess there will be some correction to it. Next numerical, I will check later on this numerical also. I guess this is correct now. A ball is thrown vertically upwards. Okay. Ball is thrown vertically upwards. Okay. Okay. With some velocity u. It has 10 meters per second when it reaches 1/2 of its maximum height. This is h by 2. Here this velocity will be 10 meters per second. This is max, h max. How high we have to find out h max? First of all, I will use the equation from this to this. For this one, can I write initial v square minus u square equal to 2a? Yes, I can use that equation as well. Now there is no issue, right? V square minus u square equals to 2gh. H is going to be h by 2 now. Perfect. Clear. So 2 to cancel out. So v square is 10 to the 100. So we have the 100, but it's also minus here, right? And the minus u. U is given to be, we don't know, equals to, so it will be positive, it will be negative here. It is g is 10, so I have 10h. So u square came out to be 100 plus 10 times h. One equation. Second would be from this to this one. This one, right? So here my final velocity is 0. We know it. I can use one more equation. V square minus u square equals to 2g h max now. I can use this one, right? So again minus, but this is 0. So positive. U square came out to be 2. G is 10, so I can have 20 h max. U square is given to be this one, no? 100 plus 10 h, 20 h. 100 equals to 20 h minus 10 h. 100 came out to be 10 h. H came out to be 10 meter. Option number C is correct. Option number C is correct. 10 meter, right? So that's all for today, right? Next thing we will discuss in next class. Okay. Thank you and bye.